This week, we are done with the hard slog of pointer analysis and moving on to much easier terrain, the terrain of test generation / fuzzing. And so this week I've picked two papers which are similar, one of them on generating C++ and C programs from scratch, and the other one on modifying existing SMT solver cases in a smart way to produce interesting cases. They both use the concept of differential testing, so that's one thing to think about. And let's look at each of these papers in brief detail before we have these student talks in greater detail. Okay, so in the C++ thing, as I said before, they generate cases from scratch. The thing is that this has been done a lot before, but each technique finds a class of things that it tends to crash compilers on. In this case, they try to do something more general, and they try to make sure that they don't exhaust the space of bugs quite as quickly as previous techniques. In the other paper, what they do is they apply a particular type of modification to existing test cases in the hope that it identifies bugs in these SMT solvers. So both of these cases find bugs in these programs. There's no guarantee of completeness or anything, but the validation is, yes, we found bugs in these programs and the developers fixed them. Beyond that, there's actually quite a lot of differences in how each of these papers shows that what it found is good. And I invite you to think about which type of argumentation you find more convincing in each of these cases. Anyway, read these papers. They're pleasant to read and they won't make you think too hard. We will talk next week.